Hello, and welcome to today's special webinar event on data modernization with Trifacta, how the Washington State Department of Health is using data analytics for a healthier world. Today's webinar is sponsored by Trifacta and produced by Actual Tech Media. My name is Scott Becker, and I'm excited to be your moderator for this event. Now, before we get to today's great conversation, there are a few things you should know about this webinar. First off, we want this to be a useful event for you, so we encourage questions in the questions box in our webinar control panel. Not only will we have team members responding to questions during the live event, but we'll also have a dedicated Q&A session at the end of the presentation where we'll discuss in greater detail some of the top questions that you ask. Second, in the handout section of your webinar control panel, you'll find that we're offering several resources. There's a Get Started with Trifacta link. There are also links to the Actual Tech Media Guerrilla Guide Book Club, as well as a link to the ATM Event Center. So I encourage you to check out those links now and share them with your friends and colleagues. Third, at the end of this webinar event, we will be awarding a $300 Amazon gift card to one lucky attendee on the live event. If you're watching this webinar on demand, I'm sorry, the drawing has already occurred. But if you're the winner, you can either enjoy your gift card or you can choose to donate the value of that gift card to one of our selected charities. So thanks to generous prize winners on previous Actual Tech Media events, thousands of dollars have been donated to charity. So thank you in advance if you make that choice today. The official terms and conditions of today's prize drawing could be found at the bottom of your handout section. Finally, one of the best benefits of this event is the opportunity to ask a question of our expert presenters. So to help encourage your questions, we have a special additional prize for you. That's another Amazon gift card, this one for $50 for the best question. At the end of the event, we'll look at all the questions, pick out the very best one, and contact that prize winner. And with that, let's get to today's fascinating conversation. So I'm really looking forward to this session with our presenters. We have Francoise Pickart she's the Senior Epidemiologist for Systems Development at the Washington State Department of Health. And we have Jeffrey Heer, CXO and co-founder of Trifacta. So we're going to get a great back and forth between two real experts on data requirements in public health. Francoise works in the Disease Control and Health Statistics Department at the Washington State Department of Health. So she's here to talk about her day-to-day challenges in preparing data for all of the important missions of the department. Analysis, reports to the governor's office, being able to share data and results with other departments and agencies in the state, with colleagues around the country, and with federal agencies, all while complying with regulations and requirements around protected health information. The department's been using Trifacta to help facilitate those vital missions. Meanwhile, as the CXO and a co-founder of Trifacta, Jeffrey knows as much about the platform, its purpose, its technical internals, and about the problems it was created to solve as anyone. So we're delighted to have him on as well. Quickly, for some context, Trifacta is a data engineering platform for profiling data, preparing data, and pipelining data. If you look at the two sides of the slide here, you can see a major design principle of Trifacta is that it's an open platform for IT and central analytics, while it's also interactive for line of business data teams. So being an open platform means it's meeting IT level concerns about multi-cloud support for Google, AWS, and Azure, about supporting consumption tools, and about having APIs to embed in a modern stack. At the same time, for line of business or departmental data teams, it's highly interactive and attuned for the needs of those LOB level team members who know better than the central IT department what the purpose of the data is and how they need to be able to use the data. So that's the level where you see the value of Trifacta's emphasis on low code, no code, on reusable macros, and on reusable templates. In the event that these LOB teams may not have developers readily available to them, they still have the power to profile, prepare, and pipeline data. So we're basically all going to be in the room here for a conversation between a technical architect of Trifacta and one of Trifacta's most informed customers, talking about how Trifacta fits into real work and daily processes of Washington State's Department of Health. I think we're all going to learn a lot over the next hour, and in fact, I think Jeffrey and Francois are going to learn things too. So let's get started. Jeffrey, take it away.
Wow. So thanks, Scott, for that introduction. And so here's the agenda for today's webinar. Well, we've already had the introductions. And so we're going to move into a conversation around data systems and public health, including current challenges, strategic objectives, and a technical use case with Trifacta. And then we'll go on to further discuss Francoise and her organization's work with CEDAR, a cloud environment for data analytics and reporting, before moving on to the Q&A. So Francoise, where are we in terms of using data to support public health?
Well, at the Washington State Department of Health, we're really trying to focus on informatics. And in public health informatics, in the informatics space, we're basically the architects and logisticians of public health data. So we really focus on designing and building systems to allow our epidemiologists to get the data they need fast enough to move it through the system. And I think something that was made really clear in the COVID pandemic is that in public health, we collect far more data than we can analyze fast enough to make decisions. And part of the challenge is, as I sort of jokingly, referenced that XKCD cartoon, is that we have a whole bunch of legacy systems that were really built for specific purposes, and they weren't really built for data integration or for modern tools. And so a huge need for us during the pandemic, but all the time, is really having tools that can clean and integrate data fast enough to actually inform the decisions that need to be made. And I think, some of the real aggravations for us, in addition, that we've had to take into account is that, pandemic or not, in Washington State, we're under a mandate to move to the cloud, which I think we all agree is a good thing. But, when the rubber hits the road, it's a lot of trial and error to figure out what does it mean to be able to move your data to the cloud in a way that doesn't disrupt operations. And on top of that, we just have a severe shortage of IT workers in the public health space. And so every time we're looking for new tools or systems, we really can't go in assuming that we're going to be able to staff up and maintain like a cohort of, say, 5 to 10 IT workers for each system. So it's really honest to find systems that are cloud native and that can also be run with fairly little maintenance for our agency.
Mm-hmm. Mm-hmm. Yeah, so moving to the cloud and a shortage of technical workers sounds like a very widely shared set of challenges across many different organizations. And so can you tell us now more about your team's specific mission?
Sure. So I think I mentioned I was in informatics. And so, those of us working to really build better health systems, and I feel confident saying we're really trying to make up for 50 years of disinvestment in public health infrastructure, especially, a failure to view data infrastructure as infrastructure. Often it's been sort of seen as a research tool as opposed to a critical system that really undergirds all of our work. And I think, I highlighted some things here because it's certainly been seen in the public space is just how challenging it's been to get good data out during the pandemic fast enough and to be transparent. And there's a lot of efforts being made on the national level to do this. Really, on practical terms at Washington State, one of the things we're really trying to do is both, find flexible tools that allow us to really rapidly process data. And again, I mentioned cloud native. We need to be able to scale everything we buy for analytics in the cloud. And another thing we're doing, and this sort of speaks to a culture, is we're really trying to develop a pipeline culture to really get away from, individual analysts having to do all the same steps on their machines, and then duplicating a lot of work. And again, finding self-service tools so that we don't need a lot of IT support. And on top of all of this, we're also really trying to build more trust in public health data. And we know that that really comes from being transparent with our methods. We often work with private data, personal, private protected health information, excuse me. But even when we can't share the data, we can be extremely transparent with our methods so that people trust the information we put out there. And on top of all of that, we look at every data source we have and think about it in terms of interoperability. And for public health, that means a couple of things. It's both getting stuff into HL7 format so that we can share with CDC and with other systems. But to me, interoperability is also about designing really easily understood data models, because sometimes, it's not about sharing access to a system or all the data, but it might be about sharing really well-designed packets of data with other agencies or with the public that allow them to use our data to better inform their decision-making.
All really important needs. What kinds of data are central to your work, and where do they come from?
So, we work with a lot of different health data, but of course, COVID has been our #1 focus right now. And so this is just an example of some of the data systems we work with. There are many, but I think, when we think about understanding the spread of COVID-19 through Washington State, that requires integrating at a very basic level, just our case data, which comes out of our Washington disease reporting system. We also have a tool called CREST that is used for contact tracing across the state. And so that has information about, people that have been exposed or contacts of a case. We also have a national system called Sarah Alert that manages our symptom monitoring. And for folks who, have had an exposure or have a positive test, these are these daily text messages you get to just check in to see how you're doing. And that informs our national and local understanding of the severity of the disease over time. And then, of course, as everyone in Washington State is well aware, we also have a vaccine mandate. And so that is really important, both for employers and for members of the public to be able to get their vaccine records easily. And so that's also required us to be able to pull in our IIS data, which is our immunization information system. So these are all really big systems with really complex data. And what currently sort of our use case when we were looking for Trifacta is that in reality, what happens every day is an analyst will download extracts from each of these systems to their computer and then try to integrate it there, either through SAS or R or Excel if they're really desperate. And so, they're trying to do all this work. And, I think like anyone who works with big data locally, they find, it just takes forever to run their queries and to try and build their pipelines. We tried moving to virtual machines and we found that didn't really solve the issue. And I think, to just point out what I like about this slide is to really show it's not just about, one analyst pulling the data. It's that we have, confronting COVID requires a cast of thousands, and we have analysts across a number of different teams, all trying to run different programs, all trying to get the same data. And so what we have is this problem just magnified across our whole response, where everyone's trying to, run simple queries to integrate data. And we have a huge problem both with duplicative work, which we always want to avoid, but also data consistency becomes a real challenge. And it's not for lack of having good standards in place, but it's just really hard, to sort of get all of those proper checks in line when everyone's already slowed down from just trying to process the data. That's really hard.
Yeah. On the issue of consistency, I'm reminded, many times I've heard from data science friends in industry that they didn't know they had a duplication and consistency problem until they hired their second analyst, and that really, hit them right between the eyes. So, can you tell us more about the data products you're producing and how Trifacta is helping you make them?
Yeah. So essentially, this is just an example of our workflow. I mean, in terms of data products, my team works upstream of, for example, public-facing dashboards or reports to the governor or a daily COVID report. But what we do is we really design and prepare data for our surveillance teams and our vaccine teams and just, everyone that needs the data to inform decision-making. And so this is a couple examples of ways we use Trifacta. On the left side, you'll see I talked a bit about building a pipeline culture. And what's really important about this, it can seem pretty basic, like, yes, you clean data upstream and then make it available to everyone. And I think the thing to realize is, public health did not have investment in technology for just, ever until really COVID. And so what that's also meant has been that while we have a lot of brilliant analysts and epidemiologists, data scientists, What we haven't had are the systems to share data centrally, the systems to really build solid pipelines. So what's been is like, if someone wants to build something upstream and share it with others, it really depends on the analyst to do a tremendous amount of maintenance on their side in order to ensure that people share data robustly. And so by having a cloud-based tool, and that's what we've used Trifacta for, what we've done is we've integrated it with our data lake. And so then the way we process data is we'll bring it in from the source systems, like the ones I showed before. We'll dump that data in a raw folder and then basically go in with Trifacta, and we'll work with folks to basically figure out how do we want to clean and process the data, where do we want to integrate it, and then we make that available in our data lake in what we call the usable folder, trying to be very obvious that this is the data that really, where we've done a lot of that like basic grunt work, to just get the data ready. Because there's a lot of work that, EPIs shouldn't be wasting their time doing when it's pretty obvious we need to go and standardize and do things. We also create some, what we like to call analytics friendly tables. And that means like this workflow here on the right is an example of how we've taken one of our largest tables from contact tracing where, it's sad to say it's over 1,000 columns long. And currently people have just been querying that table, which is kind of a nightmare to navigate. And so we worked to just break that table down into specific topic areas for analysis. And so that makes it just much easier for analysts to take a crack at. And so, for example, demographics or symptoms or vaccine data. So that way an analyst from any team can go in and say, I need to answer a question about symptoms or vaccines, and they can just get a cleaned version of the data they need to analyze without having to go through the whole process of breaking down the whole table. Another way, sorry to interrupt, that we've used it, and this I have really loved just from experience without having Trifacta, is one of the things on the left you see is a recipe. I talked about, transparency and the natural language of the recipe, which is essentially just all the steps we took, is really beautiful for us. Because I have to say, the same way it's hard to sort of have data consistency, often in public health, when we're sharing methods, we're sharing SAS code or R code because no one has the time to write up a bunch of documentation in plain language. And so having the recipe where we can quickly show folks so they trust the data that they get, to say, here's every step we took, so that they sort of know, and can trust that we've gone and done a lot of robust work. And the other one, which is perhaps my favorite feature, has been a standardization feature. And I would just say, you can hear a lot of epidemiologists will say you should never have free text in a survey because it's so hard to clean. But the reality is, every epidemic is a disease investigation. And so that means just by default, you have to develop data collection systems that have free text options because you don't know what you don't know, and so there's a lot of stuff. And one, this is, just an obvious area where people input like where they work or a city. And so, this is just a snapshot of, all of the different ways people can spell cities in Washington state. And this is even all of it. And what's been lovely is like, we have a lot of data that people simply haven't been able to use for analysis because it wasn't clean enough to do easy queries. And what this has allowed us to do is like someone on my team will take a couple hours to standardize these fields in Trifacta and then just make available a table where it's already cleaned and standardized. And this has been phenomenal for us because it really allows us to analyze data that previously would have just sat on the shelf and been considered, sort of garbage in, because it really takes like a month of someone to go through and clean it all in Excel and, arduously document. And this has just radically improved our ability to actually use investigative data to inform our, efforts to control COVID.
No, and I have to say, this is so nice to see, as I was part of the team that helped design and develop the standardization features in Trifacta. So I'm like genuinely excited to see this, put into use in this way. And I was wondering, maybe building that, could you say, I know there's lots of different data preparation tools that are out there. I mean, I think you started to speak to some, like what drew you to Trifacta in particular?
Yeah, so well, I had in, sort of my pre-COVID life, done a lot of work, in other agencies as well with things like, I like Tableau prep because it helps you prepare a data source for one, specific analysis. I've also, in my previous job, used Alteryx, which was a great tool for us in that context because we needed to bring in spatial files. But I think, really when we were looking at this, the reality is there isn't a lot in the space that does what analysts need to do. I think, there are sort of IT heavy tools like the Pentajos and Talend and Informatica, but those aren't used by epidemiologists. They're really meant for those like really heavy ETL transformations. And I found, we have Power BI. We've tried to build lots of different our workflows or different tools where we sort of jerry rig these processes. But the reality is, honestly, I mean, we had known about Trifacta for a while, and it really doesn't take long to take a look and say, okay, this is really easy to use. And so this is beautiful. And, one of the great things is because it's intuitive to analysts, we really wanted a tool that would allow advanced analysts to do what they needed to do without having to take like a week's length of courses. Not that training isn't good, but, at the end of the day, it's really important for us that the people who understand the data best can analyze their data. And often what happens in these steps is we have to pair, say, the person who really understands the data with a programmer who doesn't, because he knows how to like write specific code. And so what this has allowed us to do is to really lower the burden to being able to go in and help inform the design and cleanup of your data, especially things like standardization, which can at times influence analysis. But to really make it easy that people who need to be able to go in and mess around with the data can. So honestly, we looked at a lot, but there, Trifacta really stood out for us in terms of how we use it.
And so zooming out a bit, how does this preparation work in Trifacta fit into your larger cloud workflow?
Yeah, so like I said, we're trying to make up for years and years of not investing in the cloud really suddenly. So the key way that we've been trying to do this at Washington State, and this is all a very new project, has been what we've called the CEDAR environment, and CEDAR stands for Cloud Environment for Data Analytics and Reporting. And for us, this was really just a way to start to conceptualize what does data analytics in the cloud look like? Like what tools do you use? How do you pull it all together? And so for us, we're very much a Microsoft shop. So we went with the Azure Data Cloud. And then we really worked, we've got a lot of our programmers and, we do still have SaaS programmers moving to R. And we brought in GitHub. And then what we did is we brought in Databricks for a lot of the code heavy work. And then we kind of set up an environment mostly with Microsoft tools. And then Trifacta was actually the first like third party, not Microsoft tool that we brought in here, because we knew as we were building out that we wanted to have some, analyst friendly tools. And I think the way this works, if you look at it from the left, what we call operational pipelines really is specific to like our IT pipelines. And that's really where like our IT department sets up a pipeline that pulls data from a source system. So they sort of take the raw data and will pull and dump it into a data lake in Azure, or sometimes a Synapse database. And then basically, once it's there and it's in the cloud, then it folks like my team in informatics, as well as some advanced analysts on our epidemiology side, we then go in with tools like Databricks, Trifacta, and R, and we're trying to bring in more Python to basically go and then clean, prepare, and integrate the data and run some analytics. And so we build what we call analytic pipelines. And this is really about us going in and saying, okay, we need to set up a scheduled pull to explore and clean data. And then what we do in our usable folders, we prepare these integrated data sets that's really meant to be a place for analysts across the agency, if they have permission, to be able to go in and pull the data they need And of course, because we're able to schedule and program everything, it's always updated depending on data source at different times. But it really allows folks to go in and just say, okay, I need the latest data about this. And they get a very specific set for their needs. And then what's nice about it is they can analyze it in the tool of their choosing. So by that way, we're really not forcing analysts to, like give up an analytic tool they're really comfortable and familiar with. But we are, at the same time, making it that if you have to do, sort of robust data engineering, then we're really trying to keep all of that in these cloud native tools where we can really easily scale and manage it.
And so with this infrastructure in place, I'm curious, what issues still keep you up at night? Or if I put it more positively, what trends are you most excited about?
I will say in public health, what always keeps me up at night is the next disease. We call this disease X, or, COVID was one of those disease X's. And so I think, you're always worried about what's going to come next. And from a data side, that always means that new systems are going to need to be connected, new sources of data are going to come in. And that to me, has always really been the core of trying to work in public health emergencies, is this notion that you really can't build a perfect system and know what data you're going to need to analyze. So what we really need are flexible and resilient systems where we expect to need to bring in humans to figure out the data and understand it, because we can't write algorithms that can predict every unexpected instance or way we need to work with data. And so that's really what's always on my mind. And I think, with CEDAR, it's been a great space for us to start to, use the cloud more robustly and get these tools in place. I think, for now, because this is something so new, it's really going to be about, building out a cloud-focused analytic culture from this. So, right now we got a lot of investment for COVID and we've pushed, a lot of data systems in there. But I think, again, trying to move legacy systems onto the cloud, it's always going to be an effort. And so that's really where we keep looking to show quick wins and people how we can make their life easier. Yeah, and I think, sorry, forgot this slide. So one of the ways that, this is an example of some of these analytic tools that we use. So for example, I showed, analysts now can go in and they can pull data either into Trifacta to build a new pipeline or to integrate, or they can pull it into, a GIS tool or an analytic tool. And I think on the right here, one of the things I noted is, we did a lot of thinking about the barriers to tool use, because of course, every time you give, analysts new tools when they're already overworked and exhausted is, there's a lot of sensitivity around what does it take to truly adopt. And so we have, tools like Databricks and R and Python that are really robust, but also require a tremendous amount of programming expertise, or at least a fair bit. As well as understanding the data. And so, we looked at Trifacta as being the one that actually requires the least amount of programming expertise. So it would be a bit more democratic. And then to just sort of continue on those tools, Trifacta is really there for both program experts, data owners, and data scientists. While at the same time, these other tools are really used far more exclusively by informaticians and data scientists and the like around the agency. But you can see now what it's really allowed us to do is to really just scale and streamline our analytics so that analysts can find insight a lot faster. And that's been really critical for us, has been going through and just making sure that we're able to just give people what they need so they can go on and do their work. So that's been really great.
Yeah, coming back to your overall mission, what benefits to your organization and to Washington State Public Health have you realized if you've modernized your data stack?
Yeah, so the big benefit for us has been having a tool that works and makes it fast and easy to clean data. We've start to see some improvement in our ability to just, answer questions faster. But I think, and definitely to clean up the data. I mean, it's been really not only being able to build pipelines, but being able to work with programs, for example, that know their data really well to figure out like what data quality checks or rules should we put in place so that we can have a really transparent and collaborative process to make sure that we're putting the data together in a way that they trust and that they can work with and go forward, and to reduce the burden on analysts. And I think something that, is really hard to sort of show in an ROI, because of course in public health, our ROI is like less death and disease. And so that takes years to try and calculate. But the thing that I'm really proud of has been our ability to make available data sets that otherwise would not have been analyzed. Not because we don't care about it, because we always collect data with a purpose, but because they just became so massive and so messy that it started to just feel like in the time allotted, analysts didn't have the space to actually go through and analyze that data as robustly as they'd like to. And Trifacta's really allowed us to deal with that. And especially, on things like free text fields and notes where investigators put in that could really cross a whole gamut of different information collected, the ability to really clean and parse and model that data in a quantitative way has been absolutely critical to folks so that they could actually understand like where exposures were happening or where certain aspects of the disease trends were changing within the state.
Wow. Well, thank you, Francois, for this really informative dive into your team's work on data engineering at the Washington State Department of Health. I think at this time, it's probably nice to go. We open it up for some Q&A. So we didn't see if we have any questions coming in. Let's see. Okay. So Francois, what is the gnarliest data wrangling challenge your organization has faced?
Ooh. That's a good one. There are so many, but I think generally it's been self-reported data. And that is really difficult. And I think, public health has a long tradition of really training investigators up to ask questions the right way and to really structure responses so that it can be analyzed. And I think something that has been extremely challenging has been, when there come times when, say, we want the public to be able to say report an over-the-counter COVID test, or to bring in other data pieces, we would love to get that in, but that's been a challenge both to just collect the data. So, like finding ways for people to report it to us, but then also because it can cross such a gamut and, every week there might be a new test on the market that does things a little differently. And so it's been really challenging for us to both get that data in and then to be able to find a way to both, bring it into our data set without corrupting the quality. So, finding ways to sort of set that data at different sensitivity. And then always being able to integrate it without duplication into our existing data sets. I think, the biggest challenge, I think in every public health agency is data matching, especially when you're working with person data. I mean, we don't have national IDs that we link our data to. And unlike a health system where, if I get seen at the University of Washington, they generate a patient ID for me. But often in public health, we don't have those patient IDs. And so it can be really hard to say that someone with, this name and these values is the exact same as someone seen by a different program who has the same sort of, data entered. And so a huge challenge for us has been finding ways to match data in ways that are reliable, and accountable. And that's something where I think, I'm really excited to have more tools like this that make the work that we do transparent, because, a lot of the ways we've relied on that matching in the past has been to work with vendors who quite frankly have, a lot of IP that they put in a black box, and it's sort of like, give us the data, we'll find a match for it and then feed it back to you. And, that can be really nice, like in terms of being able to find matches quickly. But at the same time, it's a challenge because if you have a problem, we really don't know where the matching went wrong. And I think especially in order for us to be able to better share and integrate data nationally, what we want to do is create methods that any health department can use that can be shared. And so they understand sort of exactly how we're doing something, that we can develop better standards around it, that also don't leave us so reliant on extremely expensive vendors who, we basically paying to do the matching process for us.
Yeah, I think entity resolution, these classic, really hard challenges in data preparation. Let's see. We have another question here for you. How do you validate that data is of sufficient quality to inform public health policy?
Ooh, that is a very good one. The honest answer is, it's a mix of art and science. For different data sets, we expect different levels of validity in order to use it. And it's really hard if you're not familiar with it to really understand. I think, there have been a lot of articles this last couple of years, and in many cases well-deserved, about the challenge of understanding COVID data. And a lot of that has to do with the fact that, we get data from so many different places. And at the end of the day, data is used to inform making a better decision than had there been no data. And so we are very careful and very, thoughtful and deliberate about how we interpret data, which I think can be frustrating sometimes to folks because it feels like public health will take forever to make a decision. But I think, it's really important to us that we consider the provenance of data. So like lab data, is highly structured and available often in electronic systems, but often lab data can have some reliability issues, especially if you're doing an equity analysis and focused on something like analyzing by race. Well, if, asking someone to self-report their race was not a part of someone's COVID test, then the person filling out that question is not the patient themselves, which means that you're getting data reported by someone else for a question where you really don't want people guessing, what someone's, racial identity is. And so that's an area where we're constantly looking to try and improve and figure out better ways of collecting data. But the answer is there's no magic button for validity. It's really about monitoring trends. And, we do studies and tests to figure out like how valid certain data pieces are. In a pandemic, you're really trying to use the best data you have. But as the whole world has seen, you're also operating against a clock, against a very fast moving respiratory virus. And so it's really about, sort of understanding what data is available and then trying to put it in the complete picture and understanding that data doesn't tell the whole picture, but what it does tell you, can it inform your decision?
Yeah, that really resonates with other stories I've heard too, where people, some say they'd love to have a magic algorithm that tells them, oh, your data is of sufficient quality, go ahead. But really, it requires that domain expertise and all of that context. So yeah, thanks for that. And now as we wait to see if some other questions come in, Francois, I wanted to give you an opportunity if you have any questions for me and the folks at Trifacta that you'd like to pose.
Yeah, well, I think the questions I really have with Trifacta are sort of where Trifacta is going to go next in terms of additional features. I mentioned like standardization is one of my favorite features, and really just anything that makes it easier for us to almost like learn from the standardization we do, because right now we have an analyst going through and they do periodic updates, but you're always doing it on a sample of the full data set. And what I would really love is to get to a point where if we've been analyzing, and correcting how to spell Coeur d'Alene, for a couple months, that the algorithm starts picking up what we're trying to do. And what I would like to see is our analysts moving from, sort of doing the matching themselves to like checking what Trifacta is doing. So I guess it's sort of a request and an ask.
Yeah. Well, I'll go file the feature request right now. but certainly something that's of great interest to us and it's been there since kind of the beginning of the formation of the company is how can we take the appropriate machine learning or other automated algorithms and make them part of the interactive experience of cleaning data. And so with the standardization that you've brought up, obviously there's some pattern matching, there's some clustering features, but it's an open and really exciting question in terms of how can we bring even more advanced things to do some of that matching, more automatically. But also to help people with validation. It's kind of useless to do something automatically if the result is erroneous and then undermines your subsequent analysis. And so, along those lines, another area that we've been pushing on is more support for data quality, including, adding data quality rules to check that certain, constraints are met by your data. But also automatic profiling, not just to create visualizations to get a sense of what's in your data, but also to automatically suggest candidate data quality rules so that people who may know their data but be less familiar with writing queries or constraint rules, etc., can get bootstrapped and decide what's appropriate. So that as you go into these larger orchestrations and productization of your data workflows, and then the changes come in with new data batches, you can catch some of these errors that might creep in when you're already past the point where an analyst was initially setting up some of those transforms. So yeah, things that those are some of the things that keep us up at night. But we do have a couple more questions. The next one is, what top line advice do you have for others looking to modernize government data systems?
Oh, my advice is always going to be to focus on getting best in class tools for a specific purpose as opposed to trying to do an all-in-one. And I think that's been very hard because, in government, for many reasons at the, federal, state, and local level, people have tended to get money to really just make like one big purchase to improve their data systems, which often ends up being some sort of, basket of goods from one vendor. And then they say, okay, it'll do this, this, and this. And I think, what we really consistently see, especially in public health and in emergency response, is that any one tool built for purpose is going to fail some of the time. And so what we really want to do, what I really recommend, is that you really focus on tools that allow you to sort of do something specific really well, and then just having, like a really good toolkit of multiple different tools from different vendors so that you can really jump around and just meet the need of whatever comes up. So for us, Trifacta is very clearly a data prep tool. And I love that about it because it makes it easy not to confuse it with your, dashboarding and data visualization down the road, or maybe a storage tool. And I think way too often, we get caught up trying to just sort of package everything together, and then we're not happy because nothing we do is exactly what we want. And so that's really my recommendation, is just, and especially self-service. I think, there are so many phenomenal civil servants out there and really great analysts. And I always think that, if you try to upgrade your stack with a focus on benefit to the analyst, that's where you're going to win. And that can be really hard because that's not, what executives are asking for. And that's not typically how your comparisons are done or your RFIs. But I think it is possible and easy. We've created metrics to sort of measure benefit to the analyst. And when we do that to analyze different tool sets or, products, it's really made it easy for us to see what's going to win and what's going to be adopted.
That's really interesting. And also thinking about how the cloud, for example, can create an environment where you have easier access to these different varieties of tools that you're able to bring together. But really, that focus on the analyst in particular resonates, certainly very strongly, with how I see what's important in this area as well. Well, let's see. I think we have time for at least one more question here. And here's one that actually brings it back to the overarching mission of your team. And so the question is, how were the results from your team put to use by policymakers and other government agencies?
Well, so we're upstream of the reports that get made, but I think, trying to think of something that isn't too contentious, but, well, everything is contentious today, but, what's really important is that we're able to process data and get it to folks so they can find out, for example, how many cases of COVID are currently in Washington state. And so what we do directly feeds for example, the epi curves that people will see on our websites, or, right, like the pace of certain campaigns, or how many people were investigated. And so I think, that always feeds in directly to a governor's office or legislatures to understand, what is the need of the current response, and where is the disease going in Washington state. It's also, we make data available also by all of our local health jurisdictions. And so it'll feed their decisions in terms of, what do they want to support and staff up, and where do they see a need to invest more resources to try and counter the epidemic. I mean, it's, what I'm really proud of in Washington state is our government has been really focused on using data to inform decision making. And so that has been, a real benefit, is that, when we hear about new policies coming out of Olympia, it's never really a big surprise because we know where the data is going. And so since the decisions are made based on the data, it's really easy to sort of connect, like, oh, we got to here, and now this is why our policymakers are choosing to, go in a different direction or ramp up, requirements. So it's really, we really focus on upstream, getting it to analysts, but I mean, yeah, I don't know. I'm sure there are plenty of folks in Washington state that would say, what decision haven't they made based on COVID data recently? So, yeah.
No, thanks for that. Well, I think we're going to wrap up now, but Francois, I want to thank you for joining us today. And also thank you for all the work that you and your team are doing to help promote public health here in my home state here of Washington as well. And thank everyone also for attending this webinar. I hope we found it useful.
Thank you.
All right, thanks to Jeffrey and Francois. That was great. So before we wrap up, we have one more piece of business. It's the $300 Amazon gift card prize drawing, and the winner of that $300 Amazon gift card is Kyle Hirschberger from Nebraska. So congratulations to Kyle. We'll be in touch to get you your card. And with that, on behalf of the Actual Tech Media team, I want to thank Jeffrey and Francois once again for letting us in on a really great and informative conversation. And I'd also like to thank Trifacta for making this event possible. And last, but of course not least, I'd like to thank all of you for attending and for your great questions. That concludes today's event. Have a great rest of your day.